On page 6, you can find a little overview of the trigonometric values of an angle in this specific triangle. You'll find the trigonometric values of B right there and the trigonometric values of C right here. Now, how are we going to apply this? On the next page, well, we've got a triangle, a right angle triangle with right angle sides of 3 and 4 and a hypotenuse of 5. Now, what do we have to do? We have to determine the trigonometric values of both acute angles, so of B and C. Let's start off with B right here. So what we have to do is determine the sine, the cosine, and the tangent. So let's start with the sine. So the sine of B, well, if you have a hard time remembering what ratios the sine, cosine, and tangent were exactly, remember SOHCAHTOA. There you go. So the sine was the opposite over the hypotenuse. We're working an angle B, so that means the opposite is this one and the hypotenuse is this one. So we would end up with 3 over 5 and we'd end up with 0.6. Now the cosine of B, the cosine is adjacent over hypotenuse. So the adjacent right angle side over the hypotenuse, 4 over 5, and we would find a cosine of 0.8. Now for the tangent of B, so the tangent of B, it will be the opposite side over the adjacent side, while the opposite right angle side over the adjacent right angle side would equal 3 over 4 or 0.75. Now, you could repeat the entire process for C. I'll just do this quickly, but I assume you've figured it out by now that this isn't too hard if all of the angles or all of the sides are actually given. So the sine of C equals opposite over adjacent hypotenuse. Well, this time we're working C. That means this one right here is the opposite and this is the hypotenuse. So we'd end up with 4 over 5 or 0.8. The cosine of C, then we'd have to divide the adjacent side over the hypotenuse. Well, this time this is the adjacent side and this is still the hypotenuse. So we would end up with 3 over 5. And the tangent of C equals, well, the opposite right angle side over the adjacent right angle side. So this is the opposite, this is the adjacent, so that's 4 over 3. And we'll just leave this as a fraction. Now, again, the next page, the next page is rather important. A good thing to note is that the sine and the cosine, they are always in between 0 and 1. So if you find a sine or a cosine that's larger than 0 or 1, you've done something wrong. The tangent of an angle is usually going to be greater than 0, though you'll find out later that this is not always true. Okay, so we're making an agreement right here that when we're calculating trigonometric values, your answer should always be correct to 5 decimal places. So please do note that you have to round these off correctly. Well, from the previous exercise that we've done, you might have noticed that the cosine of B and the sine of C are exactly the same. Also, the sine of B and the cosine of C are the same. And while these two, so the tangent of B is equal to 1 over the tangent of C. So this is an important note as well. Now, I've already mentioned a couple of times, but if you have a hard time remembering all of those formulas, just try to remember SOHCAHTOA right here. And that should give you enough to, well, remember these formulas. So you might want to mark this, because this right here is very important. You have to know these by heart, because if you don't, you can't make any of the exercises. There you go. There are also some special ratios right here. Well, the sine, cosine, and tangent of these angles, well, they're special, but we won't be looking too much into that right now. Before you can make the exercises on starting from page 12, you have to know how to enter these into your calculator. And I will discuss that in the next video.